Okay, so let's try to apply the theorems that we just talked about. In problem 6 through 9, you're using the diagram here. It tells you that K is parallel to M. I actually put the tick marks or arrows on there, so we make sure that we know that and don't forget it. But you have segment UV, it's reflected first over line K, and then U prime, V prime, or the blue segments, then reflected over line M to end up with U double prime, V double prime, or the red segment. And then on problem number 6, you want to figure out what a translation that maps UV, that segment, onto which segment. And then you could take a look. It has to either be U prime, V prime, or U double prime, V double prime. Those are the only two segments that are on there. And it actually cannot be segment U prime, V prime, or the blue segment, because you can't just translate UV to end up with U prime, V prime. But you can translate UV to get U double prime, V double prime. So it has to be segment U double prime, V double prime. It's a segment, so you should have the little segment symbol on top as well. So U translates to the right. There's no units given. It's not in the coordinate plane as far as on a graph or grid paper, but you translate U to U double prime this far, and then really V to V double prime should be the same length as well. And then which lines are perpendicular to U and U double prime. So which lines are perpendicular? I actually drew the segment from U to U double prime. It should be lines K and M. And then why is V double prime the image of V? Explain your reasoning. So it should be the image because it's the same as a translation. Okay? Or it could also be you're reflecting over two parallel lines. And then on number 9, if the distance between K and M, so I'm going to label that in the diagram, is 5 inches, what's the length of V to V double prime? Think about that for a second. You might need to refer back to your theorem. So if you thought about it, maybe pause the video. The length of V to V double prime should be twice the distance between the two parallel lines. So it should be 10 inches. And then on this last example, you start with a key. So here's the pre-image A, and then you reflect the key or the pre-image over the line K, end up with A prime, and then you reflect A prime over the line M, and then you end up with A double prime. So this angle right here between the two intersecting lines is 60 degrees. Okay? This angle right here would also be 60 degrees by the vertical angles theorem. And you want to know what angle of rotation maps A to A double prime, because you're reflecting over two intersecting lines. That's the same as a rotation from the pre-image A to A double prime, and you want to figure out the angle of rotation. This would be the center of rotation. I'm going to call it point P, where the two lines intersect, and then the angle of rotation, maybe pause the video, see if you can figure out the angle of rotation. It should be 120 degrees, because the angle between the two intersecting lines is 60 degrees. Then the angle of rotation is twice that. 2 times 60 degrees should be 120 degrees.